order up to model, how to set order up to level. So in the previous segment, I showed you that the end of period inventory can be calculated as, or is equivalent of, as the order up to level minus demand over L plus 1 periods. So in light of this, we can observe the following. If you set S too large for the demand over L plus 1 period, you will have too much of inventory at the end of the period, right? So inventory level will be too large, meaning there will be too much on-hand inventory, and that's a problem because it will create an additional holding cost. This is a kind of too many situation, right? There is too much inventory. If S is set too low for the demand during over L plus 1 periods, then you might risk a backorder cost, right? You might have a shortage, right? And this is the case of too few. So what I want you to see is that we can observe here, again, a problem of having too many or too few units. And this is related to setting S such that it is matching somehow the demand over L plus 1 period, matching L plus 1 periods, matching this demand where there is a risk of having a cost of having too large quantity S or too small quantity S, right? These are the two cases. So in other words, this is the same situation as in the news vendor model, except now the quantity Q is actually the level S, and we want to match the uncertain demand not in one season, but the uncertain demand over L plus 1 periods. So in other words, we can use the news vendor model where we just modify the demand distribution to match the demand distribution over L plus 1 periods, and then we use the quantity Q for level S. So if we assume that the order up to model can be solved using the same logic as the news vendor model, we can try to get some of the news vendors' performance measures and try to understand what they mean for the order up to model. So in the news vendor, the first performance measure we calculated was expected lost sales. Now this measure means expected back order at the end of the period, right? This is not really a lost demand because remember we assumed in this case that all demand will be eventually satisfied. So if there is some demand that was not satisfied in a certain period, it will be satisfied in the future period, and it is just it's actually not lost. It is just delayed. Its satisfaction is delayed till a future period, right? But it is still a negative effect, and we want to avoid it. And then we expected back order tells us how much of this demand we should expect to have on back order. The other negative effect that we want to avoid is to have unnecessary inventory. In this case, the news vendor had an expected leftover. The expected leftover now will be what is the on-hand inventory at the end of the period that is carried over to the next period, right? In this case, this leftover is not like in the news vendor. In the news vendor, it was something that we had to sell at a discount. In this case, the only cost is that we have to hold it to till the next period, right? So we have some additional holding cost. Now, if you recall, in the news vendor model, expected leftover was calculated by taking the order quantity and subtracting expected sales. And in turn, expected sales was mean demand mu minus expected lost sales. So putting those two together, expected leftover is quantity Q, order quantity Q, minus the average demand plus expected lost sales. But if you recall now, Q is S, right? In an order up to model, Q is replaced by order up to level S. Expected demand is now expected demand over L plus 1 periods, right? So instead of mu, we put expected demand over L plus 1 periods. And expected lost sales, as we just said above, is now expected back order. So we can calculate expected on-hand inventory in the order up to model using this formula, S minus expected demand over L plus 1 periods plus expected back order. We can also calculate a new measure now because we now have possibly multiple orders that are in parallel, right? If L is 2, 3, or more, then, right, we have lead time of multiple periods, and we might have multiple orders being delivered at the same time. Then, right, I mean, in parallel being on order, there will be, of course, each of them will be delivered in a different period. We can calculate what's the expected on order inventory. This is, of course, an aggregation of all ordered quantities in different periods that we still haven't received. Now, if you recall, the order up to model is a kind of pull system that orders in every period the quantity that is equal to the demand of the preceding period. Then if you have multiple orders being on order at the same time, right, L orders being on order, then the quantity, the total quantity will be the same as L times expected demand in one period, right? So the expected demand in L periods will be the expected quantity that will be on order. And we can also calculate the in-stock probability. It actually is the same as in-stock probability in the news vendor model, but remember, this is now probability of being in stock in one period, which means right, that we didn't experience a stock out in the period that the order up to model assumed, 1 week or 1 day or something like that. And finally, expected fill rate will have a different formula because in this case, we have to take 1 and subtract the percentage of demand that is not satisfied, right? Expected fill rate is a percentage of demand satisfied immediately. And so what will be not satisfied is immediately is the expected back order, and out of the total demand in one period, the expected value of which is expected demand in one period. And of course, you cannot use the news vendor formula and the news vendor model formula. Here, the denominator was the expected demand mu, and this is now equivalent to expected demand in L plus 1 periods, but in the formula for fill rate, we have to put here expected demand in one period, not an L plus 1, right? So this is a different measure than in the news vendor formula.